Hello, hello. Okay, cool. All right. So, I recently got um, well, I've put together a desktop out of spare parts, and I thought it might be pretty interesting to, um, just have me show everybody how I would install an operating system into it. And as I was actually thinking about doing this, I was like, huh, why not actually just try to install Arch Linux from scratch? Like literally from like the installation guide, with no scripts whatsoever, and just see how it goes. The computer I put together is like a 6-core Xeon. It's actually not too bad, fairly recent. Sapphire Rapids, and it has like 128 gigs of DDR5 ECC memory and 2 TB SSD and older NVIDIA 2070 Super GPU. So just enough to get work done. Uh, so it's pretty much put together out of some parts I had laying around. I couldn't find a better CPU. So I think it'll work, especially for our purposes. So today, I'm just gonna record myself trying to figure out how to install Arch Linux from scratch. People say that it's actually, really hard. I personally don't think so, but for some reason, I don't know. I always surprise myself and struggle on the most useless things. So yeah, I have Arch already in a flash drive, and so have it plugged in, and all I have to do is just turn on the computer, get into the BIOS, just make sure I have some, necessary settings set correctly, like the time, any boot devices, for example, the USB drive, and also secure boot has to be disabled, or at least not for Windows. And yeah, I'll be flipping back and forth between my streaming computer and the computer itself, the one I'm setting up. So you'll find like some of this infinity mirror thing going on as like I switch back and forth like this, just to show the input source. But I don't think it'll be too bad. So yeah, let's go. So I'm gonna turn on the computer down here, and then let's actually hope that it boots. Okay, looks like the monitor is on. Uh, hello. Uh-oh. The one thing with these big workstation computers is that they take forever to post. Or is it because maybe I have quite a bit of RAM? Huh. Anyway, so it looks like the time is set correctly. And so just basic overview, 128 gigs of RAM, DDR5 4400. It's a fairly recent BIOS. Xeon W3 2423, so it's pretty much like the slowest Sapphire Rapids Xeon out there. Temperature looks pretty good, 32°C. Okay, so I want to get to this secure boot thing here just to make sure that we're not in Windows UEFI mode. Okay, so we're good here. And then I already had Fedora inside this 2 TB drive, but since it's been a while since I've done anything with it, I just want to start fresh with Arch, just go from there. So yeah, I'm just gonna boot with the USB and see what happens. So just select the Arch Linux install, and should be coming up with the Arch thing. I don't even know how to call it. Boot screen. Loading stuff from the drive. Okay. I wonder if I even have Ethernet connected. No, I don't. Okay, I'm gonna try and find Ethernet. So I'm going to. Alright, you'll hear some bunch of noise. See if I can Ethernet. Okay, this is gonna be jank. Alright. Go all the way down here. Wire it up. Wire it all up. Huh. I don't even know what Ethernet to plug it in. Yeah, I got the right one. Okay, cool. Okay. Alrighty. So I'm here in the boot screen and or actually login screen, but I don't know what to do. This is root and Arch ISO. Let's see here. Okay. Okay, so this document is a guide for actually on the right. Yeah, I'm on the right. Alright. So this document is a guide for installing Arch Linux using the live system booted from installation medium. Okay, made from the official installation image. Okay. The installation medium provides accessibility features which are described on the page. Okay, I don't think I need any of that. Okay, so Arch Linux should run on any x86-64 compatible machine with a minimum of 512 megabytes of RAM. Okay, definitely have more than that. Okay, and a basic installation should take less than 2 gigs of disk space. Okay, pre-installation. Acquire an installation image. Okay, I already did that. Verify signature. I didn't do that, but it's okay. I trust it. Prepared installation medium. Okay, the ISO can be supplied to a target machine via a USB flash drive. Okay, did that. I don't need anything else. Okay, so here's a warning. Okay, this is like standard Linux, and you're probably just disable secure boot. It just makes things harder, don't I think? Okay, so I already know how to do all this, but I want to. Okay, so now we're here. Okay, we have to start from this. Set the console keyboard layout and font. Okay, so the default console key map is US. Okay, so I don't. We have available layouts, locale, CTL as key maps. Okay, we don't need that. Okay, we want to stay in US. To set the keyboard layout past its name to load keys. Okay, we are not doing that. This is for German layout. We want to keep US. Console fonts are located in USR, share, KBD, console fonts, and likewise can be set with set font omitting the path and file extension. For example, to use one of the largest fonts suitable for high DPI screens, run set font ter-132b. Okay, I think we're considered high DPI, right? It's like a 4K screen, it's super tiny. So what was it again? It was like a set font ter-132b. Nothing happened. I think it's already because it's already as big as it can get. All right, let's see. Okay, let's look at more. USR, LSUSR, share KBD console fonts. Okay, so we have a lot more. I'm assuming that the higher the number for this ter thing is a bit better. So let's do this. Set font. I did 232b. What happens? Okay, didn't really work. Okay, already we're getting stuck. Okay, let's go to Arch Linux installation. Make font bigger. How to change a font size? I was looking at this once before. Okay, so the first thing is okay. here. Okay, so fonts. Let's see. Arch Linux font size increase. How to increase the font size? Is this Arch? No. This, okay, whatever. Let's look at the guide. Okay, so let's do set font. Let's just look at the command set font. Set font. Okay, font formats, load a default font. Okay, load all these other random fonts. Font heights. Okay. So we can use a different character height -h. Unicode options. Here we go. This is what we want. Override the font height. I don't think that's right because that's gonna make everything super tall. Oh, here, -d double the size of the font, replacing all the pixels vertically and horizontally. Okay, this is suitable for high pixel density. Let me just zoom this in case. High pixel density 4K displays. Ah, yes, this is the one I want. Okay, cool. All right. So basically, I'm gonna do set font -d. Set font -d. Oops. Huh? Okay. Set font -d per 132b. No. How come it's not? Nothing's happening. Why? How about if I did -h? If I did like 64. No. Let's see. Already we're off to a rough start. How fun. For example, the largest suitable fonts. Let me just read this real quick. From Linux 6.9, the maximum font size has been increased to 64 by 128. Okay. I32B. Okay. Let's try this again. So this is only suitable for 16 by 16 or smaller fonts. Oh, set font -d per 132n. No. How about just do 132n instead of 132b? Oh, that makes it normal or bold. This makes it bold. Already a rough start. Okay. How do I make things big? I need something big. Let's just guess. If I said, assuming we can do something like H32N, maybe there's something about that thing. Okay, so let's say set font H, was it ter H32N? No. B? No. Ter I32B? There's something different about these things. No. Okay. So what is the biggest font available here? Let's just pick something. I see a 24 by 32 Solar. Is there something bigger than that? It's an 8 by 8, 8 by 16. So 32 is literally the biggest, huh? Here. I wonder if I can change. Would it even work if I change my monitor zoom? Let's see. Let's see. Can I zoom? There should be like a accessibility thing. Otherwise, I'm just going to continue. No, that's not fair. Put others. Okay. How would I do this? This is not gonna be. Okay, let's just pick another one. 932B? No. I think that's like just the character set. D-D2. Unable to find file. What is this kernel dump? Valid next size, normal. That's not right. This is a bad user experience already. I don't like it. Okay. How do I do this? I'm stuck. Let's see. Oh, you know what? I'm gonna do this. I'm gonna use a portable monitor. I have one. Okay. Let's do it. So I'm gonna do this. I'm gonna put some power here. And I'm gonna switch this HDMI. Screw it. Okay. Then I'm gonna do this. Oh, that works-ish? Oh, that does work. Okay. Okay, I'm gonna bring it over here, just right in front of me. And something tells me I should probably restart the computer. Yeah, let's just reboot. Let's do it again. Okay, this is so much better. You know what? This is good. This is good. Okay, I'm just using a smaller portable monitor. So sorry for the last 17 minutes. This is gonna be a lot harder than I thought. Oh, did I just boot into Fedora? Oh, I just booted into Fedora. Hold on. Alright. Okay, so screw this whole Sector 132B. So much effort. Last 20 minutes. I hope I actually get something done. Okay. Alright, let's do it one more time. Okay. Boot into here. Okay. Oof. It's tiny. Why does it do that? Okay. Let's just do set font. Okay, that works. So it was just my monitor, my 4K monitor. I hope this is big enough. We're gonna roll with this. Yeah, let's do it. Okay, so we're at a big font now. Okay, so next step is to verify the boot mode. So this is cat sys firmware EFI FW platform size. If the command returns 64, then the system is booted to UEFI mode and has a 64-bit x64 UEFI. If the command returns 32, it's booted in UEFI mode and has a 32-bit one. Okay, so we basically, I'm guessing we need to be booted into 64-bit mode, most likely. Okay, let's run that command. Okay, so we're gonna cat sys firmware EFI FW platform size. Okay, 64, pretty good. Alrighty. Okay, next step. Okay, connect to the internet. To set up a network connection in the live environment, go through the following steps. Ensure your network interface is listed and enabled. For example, IP link. Okay, IP link. Okay, let's do it. IP link. Okay, yay, we do have something. ENO2NP1 that has internet. All right. So next, we want to ping. So we're fine. We want to ping archlinux.org. Sure. Ping archlinux.org. Okay, that looks okay. We're getting bytes back. Alrighty. Next step. Update the system clock. In the live environment, systemd time sync D is enabled by default, and time will be synced automatically once a connection to the internet is established. Time date CTL to ensure that the system clock is synchronized. Okay, time date CTL. Just time date CTL. Is that it? Okay, sure. Okay. Partition the disk. When recognized by the live system, disks are assigned to a block device, such as dev SDA, dev NVMe0N1, or dev MMCBLK0. Okay, those are like the disk names. To identify these devices, use LSBLK or fdisk. Okay, so fdisk L. So we're trying to identify the disks. So I have. What the heck do I have here? Oh, I'm so lost. Oh, okay. Okay, let's do that again. Okay, fdisk L. Okay, all right. So I have NVMe, dev NVMe0N1 1.82 terabytes. I already have like 3 partitions. It's a WD, so it's like a Western Digital 2 terabyte. Then I have a 115 gigabyte flash drive. And then I have one that is like 810 megabytes. And I think that's just like my BMC device in my workstation. It's for like IPMI and just remotely accessing things. So I think the disk I'm interested in is the dev NVMe0N1, which is like the first one that's being listed right now. All right, so I know that's the disk. What do we do? Okay, so what we want to do is we want to use the partitioning tool like fdisk to modify partition tables. Fdisk dev the disk to be partitioned. So this is gonna be like the dev NVMe0N1. So do fdisk dev NVMe0N1. Okay. Am I even recording? No, it's not. Okay. So I did fdisk dev and NVMe0N1. Now I'm in this tool here. It says changes will be remaining in memory only until you decide to write them. Be careful before using the right command. Command M for help. Oh, okay. Okay. So we want to like format the disk, I'm guessing. Look at instructions. Okay, all right, back to this thing. Okay, Okay, so 1.9.1. So we want to make a layout, partition layout, boot, swap, and root partition. Boot partition should be 1 gigabyte. Swap partition is at least 4 gigabytes. And root partition should be the remainder of the device, at least anywhere from 23 to 32 gigabytes. Okay. And this is if you're on BIOS, which I don't care about. I'm on UEFI. So 1, 4, and the remainder. Okay, so we have to make the partitions first, and then we'll format it. Okay, GPT. Okay, GPT. Okay, GPT. Okay, let's do it. Okay, so first we need to create a new GPT partition table here, which is what says create a new label G. Okay, and then what do we do? What do we have here? Delete partition D, list free unpartitioned place, list no partition type. Add a new partition. So we'll need a boot partition. So we do N partition number 1. First sector default starting at 2048. Okay. Okay, last sector, plus or minus sectors or plus or minus size. KMGTP. Okay, it was like 1G, 1G, 1 gigabytes. 1G, like that. Okay. Partition 1 contains a VFAT signature. Do you want to move the signature? Yes or no? Yes. Okay. The signature will be removed by the write command. Write command is the W up there. So I just write. Partition table has been altered. Calling IOCTL to reread partition table, syncing disks. Okay. So we did that. So we gotta do fthis again. This was a dev NVMe0N1. Yeah. Okay. Cool. All right. So now let's create our swap. Swap will be N, new partition. Okay, we'll recognize it. Partition 2. First sector, I guess that's correct. What was it? 4G plus 4G, 4 gigabytes. Okay, create a new partition of type Linux file system. No, I don't want Linux file system. What is this? Delete partition, list free unpartition. Add a new partition, print the partition. Change the partition type T. Partition number, which one I change to? Partition type, that we want it swap, right? Should we have also changed the other one too to be boot? Oh shit. Okay, hold on. Let's just do this one first. Partition type or alias. Type L or list all, type L. Okay, so these are all of them. See, yeah, I knew it. Yeah, we should have changed the partition type for the boot one to be EFI, I think. But it's okay. We'll work on this one first. So we want swap, and that's gonna be 19. 19? Oh wait, no, this is less. Quit. Partition type 19. Okay, cool. So we change the partition type. If I do write, okay. Now let's go back again. Fdisk dev NVMe0N1. Okay, so with change partition type, we want to do 1, and then we want to do number 1, EFI system. So 1. Okay, cool. Alrighty. Right again. Okay, we'll do fdisk. Oops. Fdisk dev dev NVMe0N1. And I think we're making the last partition, right? So that can just be the rest of the disk. Last sector. Okay, so we can go all the way to the end by default. Let's do it. Nice, 1.8 terabytes. And we can just change the partition type again. I think we just want this to be a normal one. What's normal one? Linux file system. Okay, so 20. Linux file system. Okay, so let's write. All right. Okay, so now let's do fdisk L, and look at that. All right, cool. Our NVMe has the right partitions. We have 1 gig EFI, which is going to be boot, 4 gig Linux swap, and 1.8 terabyte Linux file system. Cool. Next steps. Okay, so we need to format the partitions. Okay, so once the partitions have been created, each newly created partition must be formatted with an appropriate file system. Okay, so we want to create ext4, which is going to be the root partition. So that's like the biggest one we have. And then we're going to create the swap. We're not creating, we're formatting. Okay, we're going to format an ext4 partition, which is going to be the root partition. And then we're going to format the swap partition, which is going to be whatever, mk swap. And then we had to do the EFI one, format it to FAT32 using MKFS FAT, which is this one right here. So, okay, so it's going to be like, the way it's going to work, it's going to be mkfs.ext4 dev, and then it's going to be like nvme0n1p1, and then this will be like nvme0n1p2, and this will be nvme0n1p3. We'll just like execute these commands, and I'll just do that with the screen here. And how do I know it's like NVMe0N1P1? It's up on this fdisk list here, so that's good. Okay, so what were the commands? All right, mkfs.ext4. We want to do the root partition, so we do dev nvme0n1p3. Nice. It's like formatting now. Cool. Nice. Okay. What's next? Swap. mk swap dev nvme. Was it? What was it again? P2, right? Go know the command nvme0n1p2. Okay, 4 gigabytes. Okay, we got that one. And then we're gonna do the EFI one, which is mkfs fat f32. So we're formatting a FAT32 partition, NVMe 0 and 1P1. Nice. I think that works. Okay, awesome. What's the next step? Okay, so mount the file systems. Mount the root volume to MNT. For example, if the root volume is /dev/root partition, okay, so just mount /dev/NVMe, what was it? NVMe 0 and 1P3 to /MNT. Okay, and then after that, we have to mount what? Create any remaining mount points under mount, such as mount boot for boot, and mount the volumes in their corresponding hierarchical order. Okay, run mount with --make_dir to create the specified mount point. Okay, so we're gonna first mount the root partition to MNT, and after that we have to mount the EF5 boot partition to /MNT/boot, and this is going to be NVMe0 and 1P1. And then we also had to do the swap partition, so that's /dev NVMe 0 and 1P2. Okay, do it all in one shot. All right. Okay, so we're going to use mount dev root partition, so that's NVMe 0 and 1P3. MNT. Okay, then we're gonna do the EFI one, which is gonna be mount. Was it make dir /dev NVMe 0 and 1P. Shoot, this is boot, right? So it's 1. Okay, then /MNT boot. That looks okay. And then we do swap on dev NVMe 0 and 1P2. Okay, cool. So if I ls right now, do I see anything? No. Huh. Okay. Whatever. I don't know what I'm doing. Okay. All right. Whatever. Just keep moving. Okay. Installation. Select the mirrors. Packages to be installed must be downloaded from mirror servers, which are defined in /etc pacman.d mirror list. On the live system, after connecting to the internet, Reflector updates mirror list by choosing 20 most recently synchronized HTTPS mirrors and sorting them by download rate. Okay, so the higher a mirror is placed on the list, the more priority is given when downloading a package. You may want to inspect the file to see if it's satisfactory. Okay, and move the geographically closest mirrors to the top of the list. Okay. The file will later be copied to the new system by Packstrap, so it's worth getting right. Okay, I might as well. How do we do this? Let's see pacman.d mirror list. We just look at it. I don't know. I guess. I mean, America. I'll just show it the screen. I just left etsy pacman.d mirror list. This shows me America, so I'm in America, and I guess that's it, right? I don't know. Okay, so what do we do? I don't know. What do we do? Let's keep going. So we selected this. Okay, so we use Packstrap script to install the base package, the Linux kernel, and the firmware for the common hardware. Okay, you can substitute Linux with a kernel package of your choice. Heck, no, I don't even know what I'm doing. I'll just keep the defaults. Or you could omit it entirely when installing a container. Okay, you could omit the installation of the firmware package when installing in a virtual machine container. Okay, the base package does not include all the tools from the live installation, so installing more packages may be necessary for a fully functional system. To install other packages or package groups, append the names to the packstrap command above, or use pacman to install them while chrooted into a new system. What's chrooted into a new system? Oh, oops. Wait, where am I? Oh, okay. So right now we're actually not in our real system. Okay, we're still in the live environment. At some point, we have to get into the new system, and then we can install more stuff. I'm guessing if we try to install all the stuff right now, it's all gonna be wiped anyway. So best that we actually just install the Linux and Linux firmware, and then after that, I think we'll have a step where we can install more stuff when we're rooted. Okay, so let's do it. I mean, for sure, I know we already need like some network manager. That's like a service network manager. Where is it? This network manager here is what we'll need. So I'm gonna open a new tab here. Uh, so yeah, some sort of network configuration, and this is the one I like to use on GNOME. Network manager. I'm familiar with that one. Then we'll need a text editor. We'll use Vim. And packages for accessing documentation, man, and info page. Okay, I don't think I need that for now. Okay, so let's just do the network manager and the Vim after we install the base package and we're true rooted. So we're gonna install it all here. Okay, let's go. Let's do it. All right. So we can do packstrap -k and nt, and I think this is gonna connect to the internet that America.mirror something. Linux firmware. Okay, looks like it's downloading stuff now. Yeah, I'm on fast internet. What is it? For about 50, I'm gonna say I max out 50 megs per second. So that's like a, what is that? It's like a 400 megabit internet connection. So, not bad. Okay, that's a lot of stuff, but sure. Okay. Good thing I have a somewhat fast Xeon, I guess. I actually like this portable monitor. I might just end up using it for real. Like I just use it for like diagnosing things. But it's like an OLED portable monitor. It's kind of small though, 15-inch 1080p. But it's saving me now. So it's just okay. Missing firmware, AST. No idea what it is. I heard this missing firmware thing comes up a lot. So okay, cool. It looks like we're good. Okay. What do we do next? Okay. Let's configure the system. fstab. fstab. Generate an fstab file. Use a -u or the -l to define by UUID. Okay. So we just do that. Gen fstab -u mnt. Then redirect that to mnt etc fstab. Okay, check the resulting mnt etc fstab file edit in case of errors. Okay, sure. I think what we want to know is if the fstab that's been generated will actually have the right UUIDs. So I think to find the UUID of your device, your block device or NVMe, I think it's just like right here. You do this L, you'll see this disk identifier. Okay, so yeah, okay, let me show you. Okay, so like fstab will rely on us having like a UUID. And I think the UUID is the disk identifier when you do fdisk-l. It's like 71A64. I think that's what it is. Or I think if we do lsblk, we also see something here too. lsblk-h. Okay. SBKFS. Okay, so yeah, so we do FS, we'll also see this UUID column here. So that's how we're able to double check our FS tab. So it looks like with /MNT, the one that actually we really truly want is the 0BD9D9B0 UUID. So let's just generate and check, I guess. So we do gen fs tab -u mnt. We direct that out to mnt etc fs tab. Okay. So then we're gonna check it. So how do we check it? We're gonna have bit. We get a cat, all right? mnt etc fs tab. And then so we're here now. The output does show the 0BD9D9B0, and that is mapping correctly to our ext4 partition. So I think we're good here. FS tab looks good. Okay. So what's next? So to root. Okay, change root into new system. Okay, so this is good. We're gonna leave the live system now and we're gonna start configuring like our real system, the real like our computer now. This is no longer off that USB drive. So I think we're almost ready, I'm guessing. So arch to root /mnt. So I did arch to root. Okay, and then /mnt. Okay, so now the prompt changed color. So I'm guessing if I did ls, okay, we do have a Linux system now. Okay, but we're not done yet. We still have a few more steps. Let's go. All right. So time, set the time zone. Time zone. Okay, so it's gonna be ln sf user share zone info region city. Region city. Oh, okay. So let's take a look at this system time. But to do like that time zone stuff, geolocation. Oh, okay. So this is like, yeah, you gotta look this up. Yeah, I'm just gonna put LA time. Yeah, LA time. So it's gonna be like America slash Los Angeles or something like that. I think. Let me see. Actually, let me just double check. Uh, where we at? System time, geolocation. I have no clue what this is. I'm just say America, Los Angeles, or something like that. I think that's what it is. Okay, so then we set the HW clock sys2HC. Sure. Okay, so I'm gonna do ln sf user share zone info America, not Pacific, Los Angeles, like this. I've seen this before, and Etsy local time. Okay, looks good. Then we're gonna run HW clock hyphen hyphen sys2HC. Okay, splendid. All right, cool. Next steps, localization. All right, edit the Etsy locale.gen and uncomment enus.utf8, UTF-8, and other needed UTF-8 locales. I'm just gonna do enus. Generate the locales by running locale.gen, and then we create the locale.conf file and set the lang variable accordingly. Okay, lang equals enus.utf8, and then set the keyboard layout if we're interested. Okay, sure. Okay, so I think we need Vim now. We can download like the network manager and the Vim stuff now. I think this is a good time. So, all right. So how do we do that? We have to use this pacman thing. So pacman. I know this command. It's like pacman -s to y. Something like that. Vim network manager. Maybe. Yeah. So we're gonna install Vim. Am I even recording? Yeah. Cool. Okay, so we're going to install Vim and a bunch of dependencies, the network manager 1.5. Okay, sure. Yes. Okay, cool. So if I did, was it Vim Etsy locale.gen? Okay, cool. So I'm going to uncomment enus. Okay, so just enus. Okay, somewhere here. Yeah, we want that. Okay, cool, right? Quit. And then locale.gen. Generating locales, good. Then we want to create a locale.conf file in Etsy. Locale.conf. Okay, then add a lang en hyphen or underscore us.utf hyphen 8, something like that. UTF-8. Okay, looks good. And then we don't want to do the console stuff. Okay, and then next steps. What's the next step? Okay, so network configuration. Create the hostname file. Complete the network configuration for the newly installed environment. Okay, this may include installing suitable network management software. Okay, yada yada yada. So I already did that, I think, with the network manager. Oh, but I do need the hostname file. Okay, let's do it. Okay, so I'm gonna do Vim Etsy hostname. I'm just gonna name it average dev workstation. Okay, so we created that. That'll just contain our hostname. Okay, and then creating. Okay, the next steps is initramfs. Creating a new initramfs is usually not required because mkinit-cpio was run on the installation of the kernel package with pacstrap. So for LVM system encryption array, modify mkinit-cpio.conf and recreate the initramfs image. I don't think it's required, right? It was already run, so I'm good. Okay, fine. Next one is root password. Set the root password. Okay, I'll set the root password with PASSWD. PASSW. Okay, new password. Super secure. So secure that I'm having trouble typing it. Okay, cool. And the next step's gonna be what? What is the next step? Oh, okay. Install a Linux capable bootloader. All right. Okay. A bootloader is a piece of software started by the firmware. I know that. Okay, the kernel itself can be directly launched by UEFI using the EFI boot stub. A separate bootloader or boot manager can be used for the purpose of editing kernel parameters before booting. Okay, to successfully boot Arch, a bootloader needs to access kernel and init RAM FS image, which is typically inside the /boot directory. So we need to already have the boot partition. Okay, cool. Okay, so we get to choose which bootloader we want to install. I already know which one. Grub. I always use Grub. So let's just use Grub. How to install Grub? Okay, how do we install Grub? Okay, we already have a UEFI thing installed. Installation. Okay, okay. So mount the EFI system partition, and in the remainder of the section, substitute the ESP with its mount point. Okay, so was it? Are we already in there? Mount mkdir like this /dev/nvme. Okay, hold on. I'm gonna switch back. Okay. So it looks like we already have a boot mounted thing. So let's just see what happens. Mount mkdir. I think it's dev nvme 0 and 1p1 to /boot or /mnt/boot. Your FSI system /boot. I guess it works. I guess we don't need to do it. Whatever. Because we already have the /boot. Let's just see what's boot. What's inside boot? Okay, we already have stuff in there. So I'm guessing we're already mounted. We should still be mounted, I guess, because we didn't change anything. Okay, so then ESP is going to be the /boot. That's what ESP is going to be. Okay, so going back, we've mounted substitute ESP in this direction for the remainder of the section. Substitute ESP with mount point. Okay, /boot. Choose the bootloader identifier here named Grub. We'll just stick with that. A directory of that name will be created in ESP, so boot/boot/EFI to store the EFI binary, and this is the name that will appear in the UEFI boot menu to identify the Grub boot entry. Execute the following command to install the Grub EFI application. What command? Grub x64 EFI to so grub x64.efi is the Grub application. We want to install that to /boot/efi/grub and then install all those modules there. Okay. Okay, here's the command. All right, that's simple enough. Let's do it. Installing Grub. We do grub install target x86_64 EFI EFI directory equals bootloader. Bootloader is going to be called Grub bootloader ID. Okay, so grub install --target x86_64 EFI directory /boot bootloader ID is grub. Go. Command not found. Why? Wait, did we? Oh, we didn't install packages grub and EFI boot manager. Dang, that's sneaky. I didn't even do this step. Hold on. So this is sneaky. First, install the packages grub and EFI boot MGR. Okay, grub is the bootloader, while EFI boot MGR is used by the grub installation script to write boot entries to NVRAM. Okay, let's do it again. All right, let's install those packages. So it's gonna be pacman sy grub EFI boot MGR. Okay, say yes. Okay, let's run that command again. There we go. Installation finished. No error reported. Nice. Okay. Next steps. After the above installation, the main grub directory is located in boot grub. Okay. Read the tips and tricks for how to specify an alternative location. Nope. I'll just color within the lines. Grub install should create entry in the firmware boot manager named grub in above example. Okay. Our system is not that complicated, so we should have all our entries. Okay, secure boot, I don't care. Shimlock, I don't think that matters. BIOS, no. Configuration. On an installed system, grub loads the boot grub config file each boot. You can follow the generated grub config for. Okay, so we're gonna generate one. Okay, so we're gonna generate grub CFG. So we can generate the main configuration file. What command do we run? So we need to generate this grub CFG. So that's gonna, I think, give us the list of all the operating systems we have to choose in the bootloader. So let's just run this, the grub mk config tool. So grub mkconfig -o/boot/grub/grub CFG. Alright, simple. So grub mkconfig -o/boot/grub/grub.cfg. Okay. It looks like we found fallback init RD images, init ramfs Linux fallback. We found Linux image, VM Linux. Okay, looks like we're good here. Then I think we're good. Yeah, this doc doesn't really have much else on the grub side of things. Whoop, wait, encrypted boot, nah. Custom, nah. Yeah, I think we're good using this pager support, Windows stuff. Okay, let's just keep going. Okay, installation guide. Okay, so we installed a bootloader. Now we got to exit the chroot environment by typing exit or Control D, and then we unmount partitions with umount-r/mnt, and then finally restart the machine by typing reboot. Okay, from here on, I think we're on our own, maybe. Okay. So we do exit, and then umount. What was it? umount-r/mnt. And reboot. Okay, so we should have a new menu with Arch selected. Hopefully, if we did it right. Looks promising. We didn't totally kill the computer. Oh, nice! Arch Linux. Select that. Loading Linux. Loading initial RAM disk. Oh, sweet. Okay. Average dev WS login. So, root. Okay, we're cool. All right, good. Now let's actually do something. I don't think sudo is installed here. It's kind of like Debian, so let's just install sudo, sy sudo. Huh? Oh, are we online? IP link. Down, down, down. Uh-oh. And oh, we have Network Manager, but we never started that service to help us get on the internet. So we need systemctl Actually, can I do set font dash D? Okay, sorry. So we're doing IP link here, and then we're still down. We didn't ever start the network manager service. We installed it, but we never started it because our live environment was already connected to the internet. So we just need to do systemctl to enable service first. So I think it's called network manager.service or something like that. Yeah. And then we do systemctl to start it. So systemctl network manager.service should start, and we do IP link again. Okay, we have an up right here. Okay, so we do pacman sy to install sudo. Okay, we have that. Okay, so I know where to go from here. I'm familiar with this stuff. So now we also need to add a user. So I think it's user add -m to actually have a home directory. And I'll just say Roger. Okay, and password Roger. Okay. Okay. Now we need to actually add a group. So user, it's a group add. Sudo. Yeah. And we'll add a group to our user. So the user mod a, I think it's just the group to my user. No. G. Oh, user mod dash G dash G. Roger. Okay, yeah, roots. Roger. So now we're in sudo. Okay, so far so good. Now we have to enable sudo access for the sudo group. So it's going to be vim sc sudoers, I think. Yes. Then we're going to just kind of search for sudo somewhere. Sudo. Next. There we go. Uncomment to allow all members of group sudo to execute any command. Okay, so we're gonna just get rid of that. Uncomment it. Save. Oops. Override. Okay. And then if I actually then exit and log in as myself, I should be. Oops. Okay, so now I'm in. And now the next thing, I have an NVIDIA card, so I think I should be installing some stuff. And I don't know actually how to get a GUI. Like I know how to get GNOME, but I don't know how to install NVIDIA drivers because I have an NVIDIA card. So I'm gonna cheat a little bit. I know there's like an Arch install script, so I'm gonna just cheat a little, install those packages. I don't even know what package I need exactly, but I know where to find them in this source code. I'm gonna go to Arch install. Am I even recording? Yeah. I think it's in scripts. No, it's not in scripts. Is it in TUI? No. Is it in lib? Maybe. No. Profile? No. Holy crap. Oh, hardware. Maybe hardware. Ah, okay. So at some point we're gonna have some graphics stuff, right? And here is where they're gonna say, well, you need Xorg and Xorg init, and if you want NVIDIA proprietary drivers, you kind of need these two packages, NVIDIA DKMS and DKMS. So it just so happens that they're kind of references to here. So we need DKMS, NVIDIA DKMS, and Xorg server, Xorg Xinit. So we just need these packages with pacman. Oops. Okay, let's do it. So we do that, we can just do pack, or I need sudo now. Okay, sudo pacman sy. I think it's NVIDIA, or let's do Xorg server and then Xorg init first. Xorg xinit, and then let's do NVIDIA DKMS and then DKMS. Okay, So far, so good. Okay, it's still gonna be good 419 megabytes. Just let it go. Okay, so once we have that installed, I think we should like reboot once. And then let's see if we can get to a GUI, like GNOME, because this scares me. I don't like working like this. It's like do something silly, and I think our velocity would be better. I think we still have lots to do, like audio. We got to make sure audio works. We got to make sure like Bluetooth works and things like that. But I think we get as far as just like a GUI today, and then after that, like we'll do like a part 2 maybe. I don't know. Okay, so I'm good, and we just reboot and see what happens. So things can go good or bad. So I'm gonna load up. You know what? I'm okay. I know how to go. I know how to do this from here. Yeah. So okay. So now I'm gonna log in. So far so good. What? Okay. So I'm gonna set font D. Getting good at this. Okay. So now it's time to install GNOME. So I'm gonna do sudo pacman sy GNOME. Okay. It's gonna be a big one. So I'm gonna just get everything here. We'll just see default no-to font emoji, default Jack2. Proceed, yeah. Just download everything again. Yeah, Ethernet is so much better than Wi-Fi. It's like everything's so much faster. So, and then it's gonna be like just like a couple commands to just get it all working once it's installed. But yeah, wow, we downloaded. It's like most of the files are really small. Jeez. It's like just watching this libplacebo. Huh. Okay, well, it's taking a while. Didn't expect that. Jeez. These little loose 50 kilobyte files. We're almost there. I think the rest is going to just keep going faster and faster. Yeah, it looks like it. Or just me. And done. Now we're just going to install it. Done. Okay. Oh my god. Whew. Okay. So it has to do all this firmware thing again. Okay. All right. So then we have GNOME. So let's do systemctl enable gdm.service. I think we need sudo too. Okay. And then we do systemctl start gdm.service. So we're going to start GNOME now. And ideally, we're here. All right, cool. So we actually have. Uh-oh. We actually have a working GNOME. Hopefully, come on. Did that crash? Or is this bad password again? Alrighty. Come on. Uh-oh. having trouble. Um, oh, maybe Wayland, maybe Azurian. Alright, so we had to go back to X11 because we have stuff on X11. There we go. Cool. It was just because we had to be on Xorg. Alright, here we go. We're on Arch. We're on Arch. It wasn't too bad, right? What do we have installed here? Okay. So it looks like, oh, we're on software rendering still, so we didn't really install our NVIDIA thing properly. Okay, we'll figure it out later. We're still on Wayland, which is really bad. Uh, can we log out and get back to X11? Because this feels weird. Okay, let's do it again. Okay. Already this feels a lot better. Okay, it feels much faster, less laggy. Okay, because it's on NVIDIA card. Oh, okay. Still software rendering, but you know what? Let's call this a success for today, and we'll work on it more tomorrow. We'll see what we have. So, yeah, not too bad, isn't it? Thanks.